All right, so next up, we have the stem and the leaf plot created from the data set that we were originally given. The only problem is I don't like to work with it when it's this randomly distributed. So what I'm going to do to make my life easier is I'm going to take the time to reorganize those numbers so that they appear in order from least to greatest. Okay, so in the case of the 20s, 29 was the only number represented, so that is going to be the first number and the only number in the 20s. Okay, now when I look at the numbers that occur under the 3 stem, I've got 7, 8, 8, 9, 8. Okay, that's not in numerical order from least to greatest. So I'm going to just make that adjustment and rewrite it. So 7, 8, 8, 8, 9. Okay, and the same thing goes for the numbers in the 4 stem. I'm going to rearrange these so they appear in order from least to greatest. So I have a 0, I have a 1, I have a 2, I have a 3, I have a 4, no 5s, but I do have a 6, and then I have 2 8s. And the same thing again for the 5s. I'm going to look at that again and rearrange it from least to greatest. So I have a 0, I have a 1, a 2, and then 2 4s. Okay, so this is my new updated stem and leaf plot that goes in order from least to greatest. That's going to make it easier to do the following calculations. Mode. What is the mode? It's the number that occurs most often in the list. So if I look across any of these rows here, what number do I see the most? The answer would be 8. I should say, which number do I see the most in any single row? Okay, so yeah, there's 8s here and there's 8s here, there's 4s here and there's a 4 there. I only want to look at individual rows, and what I see is 3 8s in this row. Now, if I had used my old stem and leaf chart, it's harder to find the mode because the numbers are scattered, whereas here they're all organized in order. So no other row has 3 identical digits. So that means the mode is going to be 8, right? No, not 8. Because the stem is 3. We have to remember that all the numbers in the rows or in the leaf part are tied to these stems. So 38 is actually the mode. Okay? Range. What is the range? Well, I have to take the highest number and subtract the lowest number from it. So that makes it really easy. I don't have to go searching through this list to find the highest number. I already have it right here. 54 is going to be my highest number. And I'm going to subtract the lowest number, which obviously is 29. So what do I get when I do this? I like to use the algorithms here. And I get 25. Okay, 54 take away 29 is 25. That's my range. Okay, so the difference between the highest and the lowest speed was 25 kilometers an hour. And lastly, let's find the median. Okay, we're not working with the mean here because the stem and leaf plot wouldn't make any difference for calculating the mean because you're just going to add all the numbers and divide by however many there are. The median, however, is the middle number. So when you find the median, you know half of the people drove over that speed, half of the people drove under that speed. So I need to know first how many numbers I'm dealing with. And I can quickly count these digits to find out. 1, 2, 3, 4, 5. 19. I have 19 numbers, okay? Now in this case, the stem numbers do not actually get included with the leaf numbers when I'm adding up how many numbers there are in total, okay? So I'm only looking at the leaf portion of the stem and leaf plot to find out that there are in fact 19 numbers, okay? What gives me a nice middle point, okay? When there's an odd number, you know there will be a middle number, okay? So that means I'm going to have 9 numbers on one side of the median and 9 numbers on the other side. So I just count 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 10th number. So 43 will actually be the median speed. Okay, so there's 9 digits before that, 9 digits after that. And that tells me exactly what I need to know. Mode, range, and median of this radar speed data set in the form of a stem and leaf plot. More on that later. Thanks for listening.